Unit 9, Lesson 1, we are going to sketch each angle and identify which quadrant it lies in. Then we'll convert from radians to degrees, and we'll do that afterwards. So how can we quickly do this without directly looking at the unit circle that you may have created with me in the tutorial I provided before this lesson? I'm going to identify the denominator, and I'm going to ask myself, can I easily convert this into a number of 6 or 4? The reason for that, as we come back here, the ones that we have memorized or are going to memorize are denominators that have values that are divisible by 6 or 4. Remember, 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, and so on. 1 pi over 4, 2 pi over 4, 3 pi over 4. So, can I turn a 3 into a 6 or 4? I can, in fact, convert it into a 6. Now, how do I do that? I can only do that by multiplying or dividing. And in most cases, we'll multiply. So whatever I multiply to the denominator, I must also multiply to the numerator so it doesn't change the value of the original fraction. What does that mean? It means 4 pi over 6 is equivalent to 2 pi over 3. Now, why did I do that? Because now, knowing that the bottom is of a 6, I'm going to, in my mind, think about 30-degree increments. It's positive, so I start here and I'm counting up by 3s. So here we go. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is the measurement of 2 pi over 3, which is equivalent to 4 pi over 6. It lands in quadrant number 2, and now to convert it into degrees is simple. 3, 6, 9, 12, 120 degrees. Let's take a look at number 14. 14 already has a 4. I don't need to change anything. So I'm counting by 4s. So remember, 4s are going to be the 45-degree measurements. Now, some students often forget to count at the axes. So we start here, we haven't counted. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 over 4, 6 over 7 over 4. So all the way here, it's directly in between 270 and 360. This is quadrant number 4. And if we convert it, if we convert it, it converts into 350. Oh my goodness. It converts into a measurement of 315 degrees. Don't forget about putting the degree symbol. Now, what's another way that we can convert that? Well, a couple different ways we can do this. When we have radian measurements and we need to convert it into degrees, instead of multiplying by 1 pi over 180, we're going to multiply by 180 degrees over 1 pi. The pi on top and the bottom, they don't just disappear or cancel out. In fact, they reduce down to 1. In your mind, again, you may see them just disappearing. In fact, they do reduce down to 1. So I want to take 7 times 180, get an answer, and then divide by 4. 7 times 180 and then divide by 4. I should end up with 315. If my calculator was able to show you and it did not provide, let's see. Oh, it's looking good right now, so let me move this off to the side. Perfect. I'm going to take 7 times 180, 7 times 180, get an answer, divided by 4, and we end up with 315 degrees. Let's look right now at number 15. I already have a 6, so I don't have to convert it into a 6. I'm going to count 11 times, and I'm counting here by 30. So I don't start counting at this beginning starting line. I count once I move. 1 over 6, 2 over 6, 3, 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6. Okay. So we are landing in quadrant number 4, and now let's convert it. So I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. 33, make sure to add that 0 afterwards. Now, I've started and gone upwards because these are positive. When it is negative, remember that I have to reverse direction. Great, I already have a 6 in the bottom. Let's count here. So 1 over 6, 2 over 6, 3 over 6. Now, if you remember, one time around is 12 pi over 6. Let me show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One revolution is 12 pi over 6 before I reduce it. And now I still need to go up to 13. So I'm going to go one full revolution plus one more 30-degree increment. This lands in quadrant number 1. And now let's convert it. So I have 360 plus an additional 30. 360 plus an additional 30 is 390 degrees. Now, if you weren't comfortable doing that, remember you could always take the 13 pi over 6, and when we convert 13 pi over 6, and when we convert from radians to degrees, we're going to multiply by 180 degrees over 1 pi. The pi's, again, you may think they've disappeared. They really reduced down to 1. I'm going to take 13 times 180 and divide it by 6. Now my calculator isn't glaring. This is wonderful. I'm going to take 13 times 180 and divide it by 6. I end up with 390 degrees. All right, we already have a 4 on the bottom. Wonderful. So I'm going to count by 4s. So right here's 1 over 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, 4. So I've already done one revolution. 9, 4, 10, 4, 11, 4, 12, 4, 13. So all the way over here. This is landing in quadrant number 3. And now let's convert it. So I have one revolution, that's 360, plus I do another half of a revolution, which is 180, plus an additional 45 degrees. All right, so I'm going to add those up quickly, showing you multiple ways to achieve the same answer. And we can see that the answer should be 585 degrees. Now, if you're not comfortable with that, you could take 13 pi over 4 times, again, going from radians to degrees. I'm going to multiply by 180 over 1 pi. Pi's, again, are going to reduce down, and I'm going to take 13 times 180, get an answer, divide it by 4, and I come up with the same answer, able to achieve the same answer. 6 of them on the bottom. Wonderful. 1, 2, 3, 4, 5. Now, I'd be counting a lot here. Remember, one revolution is 12. So, one revolution, there's one revolution. Now, if I go around twice, I'm up to 24. If I go around 3 times, I'm up to 36. And I can see this is slightly more than 36. So, here's 12 pi over 6. Here's 24 pi over 6. Here's 36. Okay, I'm at 36. I've gone around 3 times. 36. 37, 38, 39, 40, 41. All right, so this is in quadrant number 2. And now let's convert this into degrees. So to convert this into degrees, I'm going to go ahead and go, I've done 3 revolutions, and each revolution is 360. So I have 3 times 360 because I've done 3 complete revolutions. And then I've done how many groups of 30? 1, 2, 3, 4, 5. 5 groups of 30. So this is one way to achieve the answer. 3 times 360 plus 5 times 30, and I get an answer of 1,230 degrees. Now, is there an alternative way if you don't like breaking up like that? Sure. 41 pi over 6 times, to go from radians to degrees, I'm going to take it times 180 over 1 pi. So I'm going to take 41 times 180 and then divide it by 6 to come up with the exact same answer. All right, so we're going to be doing the same thing here, but there's a few that may confuse us. The first one is a negative 3 pi over 4. What I love about this is we already have 4 in the denominator. So instead of me going and doing upwards or counterclockwise, a negative says we're going to reverse it and go counterclockwise. When I count by 4s, I'm counting by 45-degree increments. I don't start counting until I move. So here's 1 over 4, reverse it, remember, 2 over 4, 3 over 4. So it's going to go here, and it's going to end at this position. So this would be the place where I can locate 3 pi over 4. This is going to be in quadrant number 3. And now let's convert it. Let's convert it. So I want to take this measurement. Now, what is this? Okay, so I have 90 plus an additional 45. So some of you may go 90 plus 45, and you get a negative 135. The negative sign, remember, needs to follow down. It means we reverse directions. Others are like, that's too confusing. So what's an alternative way? 3 pi over 4. To convert it, I'm going to take 180 divided by 1 pi. The pi's, again, are going to reduce down to 1. that negative sign is going to jump up with the 3. So negative 3 times 180, I'm going to divide it by 4, and I get the exact same answer. Remember to put a degree symbol on it. Now, when I look at number 20, it doesn't have a 6 and it doesn't have a 4. So I need to transform it by keeping the same original value. Now, how do we do that? Whatever I multiply by the denominator, I must multiply by the numerator. This is equivalent to negative 10 pi over 6. Because I see a 6 in the bottom, in my mind, I'm counting by 30-degree increments. Okay, so I need to reverse direction. 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7, 6, 8, 6, 9, 6, 10 over 6. So it lands in quadrant number 1, and now let's convert it. So again, you may go 90, 90, 90, and 90 and 30. So I have 3 groups of 90 plus an additional 30 degrees would be 270 plus 30. Okay, remember it's a negative, negative 300. That's how you may do it without a calculator. Remember, half of your advanced placement exam, you do not get to use a calculator. Others may choose to take this negative 5 pi over 3, the negative sign is going to push up with the numerator, and take it times 180 over 1 pi. The pi's are going to be reduced, and I have negative 5 times 180 divided by 3, and I achieve the exact same answer. Now, a number 21, remember we're trying to convert it into a 4 or a 6. Now, I can convert this into a 4, taking it times 2 and times 2. I can convert it into a 6 times 3 and times 3 on top. It doesn't matter whether you turn it into a 4 or to a 6. You'll achieve the exact same answer. So I'm going to take it times 2 and times 2. I end up with negative 18 pi over 4. Now, when there's a 4 in the bottom, I'm counting by 45s. The negative sign means I reverse direction. So 18. 1, I'm going to make these little marks here so we can see them. 1, 2, 3, 4, 5, 6, 7, 8. Well, if 1 revolution is 8, and I need to get up to 18, I need to go at least 2 revolutions, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've done 2 revolutions, reverse direction. I'm up to 16, I need to go 2 more. 16, 17, 18. So where does it land? It lands on the y-axis. It lands on the y-axis, and now I need to convert this. So I have 2 complete revolutions. Well, that's 360 plus 360, and I'm putting them as negative because we reversed it. And then I have a 90 degrees plus negative 90. Now, this is 720, 720, 820, negative 810 should be my correct answer. Is there another way we can do that? For those that prefer to do negative 9 pi over 2 times 180 over 1 pi. Let's take negative 9 times 180 and then divide it by 2. I get the exact same answer. You can't see it, but there it is. All right, so I can't easily convert this into a 4. I can convert it into a 6, which is equivalent to negative 32 pi over 6. Now, if I go around and count, I have to go reverse. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 1 revolution is 12 pi over 6. Well, 12, that's 1 revolution. And if I go a second revolution, I'd be up to negative 24. If I go a third revolution, so I'm counting by 12s, 12, 24, 36, that'd be too much. So I need to go at least 2 revolutions. So this is 12 pi over 6. Here's another 12 pi over 6. I'm up to 24, and I need to get to 32. So I'm up to 24. 25 over 6, 26, 27, 28, 29, 30, 31, 32. So it's landing right here. So 2 full revolutions, and then I'm going to count 26, 27, sorry, so at 24, I'm going to be at 25, 26, 27, 28, 29, 30, 31, 32. All right, so let's quickly convert this now, taking it times 180 over 1 pi. And I'm going to grab the calculator. Don't forget about the negative sign. That's a common mistake. And I end up with a negative 960 degrees. Negative 960. If this is negative, this will be negative. If this was positive, then this would be positive. All right, so here's a tricky one. Let's look at number 23. So number 23 is not a degree. So I'm just write no degree right now. This is not a degree measurement because we don't see a little degree symbol. So it's like we've already taken this portion. If I come back to 22 and did negative 16 pi, and I'm going to divide it by 3. So it's like we have a numerical value. We have a numerical value. So we need to figure out, where does this land? Well, I know that whether I go by 4s or 6s, for instance, let's go by 6s. 1 over 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Right here, all the way to here, is 6 pi over 6, which is equivalent to 1 pi. So let's figure out what 1 pi is. 1 times pi, well, 1 times 3.14. Okay, so from here all the way to here, this is about, at this point, is approximately 3.14. And I need to go to 3. So that's slightly above it. That's slightly above it. So I know that I'm in quadrant number 2. Now, how can I convert this into degrees? This is not degrees. We see no degree symbol. What I know is I know that 1 pi is equivalent to 180 degrees. And I want to figure out, what is this degree measurement? I don't know the degree measurement, but I know that we have a measure of 3. I know we have a measure of 3. So now, in order to figure out what it's equivalent, so degrees are on the bottom, my radian measurements are on top, I'm going to cross multiply. 1 pi times x is 1 pi x, and 3 times 360, well, 18 times 3 is 400 or 540 degrees. And now I'm going to divide here by pi, and we'll figure out what x is. So I'm going to take the 540, and I'm going to divide it by pi, and I end up with 171.887, depending on how they want us to round. 171.887 degrees. Again, we went up and all the way to this part. Now, this one is negative. So let's take a count. We know that from here to here would be approximately negative 3.14. So if this is negative pi, negative 1 pi, this would be negative 1/2 pi, right? Because this is half of a pi. Let's figure out what negative 1/2 is. So negative 1 pi divided by 2. So this is approximately negative 1.57, and I want just negative 1. So I want less than negative 90 degrees for those who really like working with degrees. So maybe somewhere in here, we'll achieve this answer of negative 1.57. Now, how do we convert this into degrees? How do we convert this? We know that 1 pi over 180. So 1 pi is equivalent to 180 degrees. We want to know what the degree measurement is, and we have a negative 1. So I'm going to multiply to get negative 180. I'm going to multiply here to get 1 pi x. And then I'm going to divide by pi. So I have negative 180 divided by pi, and I end up with negative 57.295. Now, if we rounded that, it'd be 296. This matches up with his answer key.